So exponential growth is basically self-explanatory. It's in the name. It's literally something that grows exponentially. It's what you want to see your bank account do, is to grow exponentially. If it's going the other way, you're doing something wrong. So there are many important applications of exponential growth. For example, when scientists are looking at like a bacteria or like just a sample of something, they want to see how fast it multiplies, how much it grows. Yeah, and it comes to compound interest. So that's how much when you invest a certain amount of money over the years, and you have a certain interest compounding at a specific term, and for population growth. Okay, so those are the applications of exponential growth. So exponential growth, we're just looking at an exponential function. So basically something to the power of x. So a number to the power of x, that is something that's called an exponential function. So it's f of x is equal to a times b to the power of x, where the value of b has to be always a positive number, and that positive number always has to be bigger than 1. So it cannot be 1. 2, 3, 4, 5, 6, 7, 8, whatever, that can be used for your base of the exponential function. So this is a graph of the exponential function. So as you can see, what do you notice about the function? Does it ever cross my x-axis? No. So my exponential function will never actually hit 0. Only, do you guys know the reason why? Okay, if I have a negative exponent, what do we always do to turn that exponent into a positive? So let's say I have f of x is equal to 2 to the power of x, and I'm asking you guys to solve for x is equal to negative, let's say 20. So if I plug in x for 20, I'm going to get f of x is equal to 2 to the power of negative 20. How do I change that so it becomes a positive exponent? You flip it. And we know that this is going to give me a very, very small decimal that is close to 0, but is not actually 0. So let's see what the hell this is. 1 divided by 2 to the power of 20. 0.0000953. So it's technically not 0, which means that you can never cross 0 on an exponential function. Because even though we have negative exponents, it will never give us a negative value. So when it comes to stuff like calculating a compound interest or calculating bacteria and the bacteria multiplying or calculating population growth, we're only going to focus on one specific formula, and that's the formula you're just going to use for this lesson. So I'll let you guys copy this down, that important piece of information. So when we have exponential growth, it can be modeled by the following. So P of n is equal to P0 times 1 plus r to the power of n, where my Pn is the final amount. So that's just a fancy way of saying final amount. P0 is the initial amount. And the rate, it represents the rate of growth. But whenever we put it into the equation, we have to change our percentage into a decimal. So do you guys remember how to change a percentage into a decimal? Yep. So for example, if I have, let's say, 32%, how do I change that to a decimal? Yep. Which gives me what? Yep. So that is the value you would put for your R. Is the decimal, not the percentage. You have to convert your percentage into a decimal. So if something is doubling, the rate is 100%. And I'll give you guys a practical example. So say at the casino, you start off with $100 and you make $100, you made double your money, right? Because you made 100% of it back. You started with 100, you made an extra 100, which means you made 100% of your money back. And if you made only $50, then you made 50% back, because 50 out of 100 is 50%. So we have a biologist grows a colony of 100 bacteria in a petri dish and finds that the quantity increases by 50% each day. So I want to determine algebraic formula that can be used to describe the quantity pt after t in days. So it says that my t, so my exponent, is going to be in terms of days. So we're going to use our general formula, which is up here. So p of n is equal to p0 times 1 plus the rate to the power of n. So what was our initial amount of bacteria? P0 is equal to 100. So what is our R as a decimal? Olivia. Yep. So 50 divided by 100, which is 0.5. And instead of n, what do they want us to use for the time? I underlined it already. T. So instead of P of n, we're going to use P of t. So I'm going to have P of t is equal to 100 times 1 plus 0.5 to the power of t. So this is my answer for A. So that's my equation. Yep.
So the PO, like PO is just one number together.
Yeah, PO is just one thing together. And that's just a fancy way of saying the initial amount, or how much you had at the beginning. So for question B, it's asking us to determine the quantity after 10 days. So what do you guys think I'm going to sub in for T? What number? 10. So P of T is equal to 100 times 1 plus 0.5 to the power of T. Wherever I see T, I'm going to plug in the number 10. So P at 10 is equal to 100 times 1 plus 0.5 to the power of 10. So because of BEDMAS, we're going to add the numbers inside of the bracket together. So I get 100 times 1.5 to the power of 10. So when you get to this step, you're going to do your exponent first. So you're going to do 1.5 to the power of 10, and then you're going to multiply that by 100. So you guys can try that and tell me what you would get as your answer. We'll do 2.
Why is it 1 plus 0? Why is it 1 plus 0?
Because there's just a notation of the formula.
Oh.
Yeah. So Ashton said an answer. Let's see if everyone else got the same one.
Okay, hold on.
Did anyone else get it? 1.5 to the power of 10 times 100. Everyone got that?
What's the answer?
5,766.5. So you can say, therefore, after 10 days, you have a colony of 5,766.5 bacteria.
Such a golden retriever. What does that mean when it costs more?
Okay, so make sure you're copying this down. So it seems pretty simple so far? Okay. I know, right? Better than exponents. Well, the first exponent laws is easy. The second one with the fractions, you guys kind of just went like, what is this?
don't understand fractions. I never did.
Fractions suck, right? They're terrible.
Maybe you should just not give us a test on it. Yeah.
What if it's open book?
Oh, then. Oh, what?
Yeah, I usually make my last unit test an open book one.
Okay, it's an open book one? Watch us. Yeah. He's like, what'd you say about this?
That's true. I did it one time and no one got perfect.
Oh, yeah, with your grade 9s, right?
No, with my grade 11 college class at St. Martin.
Nobody got 100?
No, not 100.
That's sad.
I know, right?
I'm scared.
Okay. So, next one. So this is when it comes to money and you double money, this is what happens when you double money. So, suppose you're given a choice between two gifts. The first is $10 million in cash. And the second is an account that starts with $2 and it doubles each day for exactly 24 days. Which one should you take? So option one, my Apple Pen's gonna die soon. I gotta hurry up. So if option one, we don't have to do anything because you're given $10 million, which is a ridiculous amount of money. Mhm. So for the first one, I don't really have to do math. For the second one, however, because my money is doubling, what is my rate in terms of a percent? Because my money doubles, so if my money doubles, what's my percentage I get back? It says on the first part, if you look up, 100%. So option two, we're gonna have to create a formula. So P of n is equal to P0 times 1 plus R to the power of n. So what's our initial amount in option two? How much money do we start with? $2. N. And what did we say my rate was? 100%, right? So 100 divided by 100 gives me 1. So whenever you're making 100% back, that means you're doubling your money. And what is my N? How many days am I doing this for? So I'm going to have P of N is equal to $2 times 1 plus 1 to the power of N. So now I'm just going to plug in 24 for N because I'm doing this for 24 days.
Wait, so where did you get the R with the 1?
Because so when you double your money, you make 100%. So that would be your rate. So remember, to turn 100% into a decimal, you just divide it by 100.
Oh, right. Okay, sorry.
Yep.
24 for everything else.
Because I want to show you the general equation first, and then you plug in the 24. So I'm going to get P at 24 is equal to 2, and then do the bracket. 1 plus 1 is 2 to the power of 24. So again, same thing. Do your exponent. Do 2 to the power of 24, and multiply that result by 2. And let's see what you guys get. It should be a pretty big number.
It's a big number. I don't know how to say this.
What, 33 million?
Yeah, 33 million. 554,432.
What? I can't even say this. Oh, 30.
So this is unrealistic because you're never going to double your money every single day. It's just showing you that compound interest just works in a very strong way. Okay? When it comes to investing and you're making money, you're like the happiest person in the world. But if you're losing money, you're like not the happiest person in the world. Yes, Cynthia.
Never mind.
So which option is better?
I'm kidding.
So that's why also compound interest is why banks want you to take longer mortgages because you end up paying more in interest, which is why they dislike people who pay mortgages off fast because they don't make as much money off of them. Yeah, so banks, yeah, like I was telling my grade nines, banks really dislike. So for number three, it's simple. So you're gonna use the same general formula. You have the population in a small town is predicted to grow at a rate of 8% per year. Currently, there is 25,234 people in town. I just want you to determine the formula to calculate the population in 20 years. So do that on your own for a bit, and then I'm going to come around and check your answers, and then I'll post the final answer on the board. Content with that? So we got, again, we start off with our generic formula. P to the Pn is equal to P0 times 1 plus R to the power of n. Our P0 is the initial amount of people, which is 25,234. Our rate is 8%, but because we have to change it into a decimal, you divide it by 100. So 8 divided by 100 gives me 0.08. And for our n, it's the amount of years that we're doing this for, which is 20. So our population can be P of n is equal to 25,234 times 1 plus 0.08 to the power of n. And because n is 20, I do P of 20 is equal to 25,234 times 1.08 to the power of 20. Because it's asking me to just write an equation or a formula, I can just leave it at that. If I ask you to solve, what was the population? 117,000?
117,614.
614?
Yeah.
Okay. Because it's people, you gotta leave it as a whole number.
Oh, then 615.
615. Okay. So how is this lesson compared to the last one?
So bad.
So much better, right? Okay, so do your work.
Wait, but do you have